Such a good job recording videos, and it's gone all downhill today. So let's see if I can make it through a whole video here without having to record it twice. Today, we are talking about conditional probability. It's the same thing we did last section, a little bit more about understanding the vocabulary and what it's actually asking. But if you can get past that, pretty easy. Same thing we did last section, only they're going to give us a nice table here with a lot of information. Okay, so first one here, it says on April 15th, 1912, the Titanic sank. They gave me a table here describing what went on the Titanic. So you've got a table for or a row for first class, second class, and third class passengers. And we have whether they survived or not. All right. And using that information, we're going to answer some questions about it using probability. We are doing both fraction, or all three: fraction, decimal, and percent. And so the first question says, what is the probability that a randomly selected passenger was in first class? So if I want to be in first class, and I'm picking randomly from everybody. And so on bottom, I'm putting the total amount of people. Well, the total passengers is 1317. So that's what went on bottom. If I want to know they're in first class, I'm going to the first class and go into the total, which would be 324. So that's where I got this 324 over 1317. Once I've done that, this is where we had issues. We type that into our calculator, 324 divided by 1317. I get this decimal. It's let's go 3 decimals here just because, 0.246. So this is the same as 0.246. And then it also asks us to write this as a percent. So I'm also going to say that's equal to 24.6%. Remember, if you want to make something a percent, you got to move that decimal spot 2 places. So there's a 24% chance, about a 25% chance that if you pick someone randomly, they are going to be in the first class. If one of the passengers is randomly selected, what is the probability that that passenger survived? So again, we're picking randomly from all of the passengers. So again, our bottom number is 1317. I want to know that they survived, so I'm going to go to the survived column and go to the total, 500. So 500 divided by 1317. So 500 divided by 1317. 3 decimals, 0.3796. So we're going to round that to 0.38 if I round that up. So this is the same thing as 0.38, which is the same thing as 38%. We move that decimal 2 spots, make it into a percent. So about 40% of the people actually survived. So not even half. What is the probability that a passenger on the Titanic was first class and survived? All right, so first class and survived. So we're going passenger on the Titanic. So again, we're over 1317. First class and survived. So I would want to look at, oops, I just messed that up. I want to look at first class and survived. 201 people were in first class and survived. So that goes there. 201 divided by 1317. 15 or 0.153. 0.153 is the decimal, or 15.3%. Find the probability of a second class passenger. And so this is just the probability of everyone because they're not telling you otherwise. So it's out of everyone. So out of 1317, I want a second class passenger. Second class is 284. So 284 over 1317. 284 divided by 1317. Boom, 0.216. 0.216 and 21.6%. There we go. That's it. We could get a little bit more into it, and let's do that below. Remember, if we see this, A over B, the probability of A over B, what is the probability that if someone falls into category A and B out of all of the events? The probability of event A given event B. So I'll kind of explain that as we go. If one of the passengers is randomly selected from the first class passengers, so we're not picking from the full group anymore, we're just selecting from the first class passengers. Well, how many first class passengers do we have? That is this number right here, 324. So that now is my bottom number. Given that they're in first class, what is the probability that that passenger survives? So all I'm going to do now is I'm going first class survived, so 201. So 201 divided by 324. 0.620. So that's the same thing as 0.620. Or if you were in first class, you had a 62% chance of surviving. What is the probability that if the passenger was in third class, given that the passenger survived? So this is the given. We're going given that the passenger survived. So I'm going to look at the survived total, so 500. And above that, we're going to pick the survived people that were in third class. So survived in third class is 181. So out of all of the people that survived, 181 of them were in third class. So 181 divided by 500. We get that 0.362, or 36.2%. So 36% of the people that survived were in third class. What is the probability if you selected 2 people from the Titanic that you select a first class passenger who survives and a third class passenger who does not? All right, so we're making a distinction. It's got the word "and" in it. So you're picking 2 people from the Titanic. What is the probability that you select a first class passenger who survives and a third class passenger who doesn't? So the first person we're picking is a first class passenger who survives. So how many do I have to choose from? Well, I have 201 first class passenger that survived out of a total of 1317. I want to pull this one, and then I want to pull the next one. And so my next one that I'm doing here is a third class passenger who does not. All right, so a third class passenger who does not survive. Third class does not survive is 528 out of 1316 because I picked one out in the first one. So there's my setup. Let's multiply that. 201 times 528. That's what goes on top. And on bottom, on bottom is 1317 times 1316. This is my setup. Now, I am reading this question a little bit different. I am doing this that I'm selecting the first class passenger first and the second class passenger second. It's a little bit different than what we were doing the other way, but that's all right for what we're doing here. So what? 1,106 over 1,733,172. That's that. Then we are doing sorry, I'm going to adjust. I was reading that question. I think I was reading it wrong. I would like to do it the different way. So again, sorry, go back to this. What is the probability that if you selected 2 people from the Titanic, you select a first class passenger who survives and a third class passenger who does not? All right, so this is probably a little bit more detailed and maybe I'm reading into it a little bit too much. But first class, 201. Third class is 528. So we're going to take 201 times 528. This is probability of A happening, and this is the probability of B happening. We're taking those two numbers and putting them together. And we're going to divide by me selecting 2 random people. And so this is the combinations of things that would be good out of the total combinations. And well, what do we have? Well, we have 1,317 people, and we're going to choose a group of 2. So I'm taking 201 times 528 on top, and I'm choosing a group of 2. So I've got this 1,006,128. That's how many correct answers there are, divided by 866,586 total people. So if I do that, I get 0.122. So this is 0.122. I'm not writing the fraction here because it's pretty deep. Or 12.2%. That's pretty good chance that we're picking 2 of them and we're picking out of the right category. But there's a lot to choose from, 201 and 528. So Together, we're putting that together. Again, why did we do that? It was an and statement, so we multiplied the two right numbers. I want to pick two people at once. It wasn't pick one and then the other one. Order didn't matter there. We were going NCR. That's why it was a little bit different. Sorry about that. Let's go to the next one. Find probability they did not survive. Remember, this little line right here means given they were in second class. So we're going second class is our total. So we're going to second class. There are 284 total people. Probability they did not survive. So if given they're in second class, so I'm only looking in this row, they did not survive was 166. So 166, that looks weird. 166 out of 284. So that's my fraction. 166 divided by 284 is going to get me 0.585 or 58.5%. So almost 60% of the people, if you were in second class, you didn't survive. What's the probability that you were in first class and did not, given that you did not survive? So we're going given did not survive. So we're only looking in this category. So how many people did I have to choose from? 817. Given this, so that's the only column I'm looking at, 817. Given you did not survive, how many first class people did not survive? 123 goes on top. So I'm taking 123 divided by 817. Type it in, hit enter. I get 0.151 when I round, 0.151. So only 15.1% of first class people did not survive. Or, I'm sorry, of the people that died, only 15% of them were from first class. That's what we just learned. Hopefully you can see some, well, not hopefully, but maybe you're seeing some data there that's telling you they were not proportionally deaths compared first to third class and so on. All right, so let's keep this going. Junior high students were asked about their favorite subject. So 7th grade, 8th grade, English, math, history, other, boom, 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 boom. We're going to find some probability. So I'm going to go ahead and hit pause and find the total. So if I wanted to find the total amount of people that picked English, I would take this column and add it together. So I would take 38 plus 47, and I get 85. I'm going to go ahead and hit pause and fill in the other ones. So again, to get these numbers, I just added the total and went here, added the total, went here. To get the final amount of people, I added this way, and I got 298. And technically, if I did this way, I'd also get 298. I checked my work by doing it that way. So find the probability that someone is in the 7th grade. So out of all of the students, well, there's 298 students. How many people were in the 7th grade? 116. I'm just going to leave it at that. I'm confident that you can do more. Find the probability that English was their favorite and they're an 8th grader. So there's no distinction as to which group we're looking at. So we're looking at the whole thing, 298. Probability of English and 8th grade, that would be that number right there. So 47 out of 298 people had said English was their favorite and they were in 8th grade. What is the probability that a randomly selected student in the 7th grade likes history? So we're picking one randomly from the 7th grade. So out of 116 people, what's the probability they like history? Well, I need to look in the 7th grade. Just kidding. And look at history. It'd be 36 out of 116. What is the probability that a student's favorite subject is math or science? I don't know why they lumped us together. This is a math problem. They couldn't separate math and science, but their favorite subject is math or science, given that a student is an 8th grader. So given that they're an 8th grader, so I'm only looking in the 8th grader column. So my total number is going to be 182. Favorite subject is math or science, 72. What is the probability that a student is in 7th grade, given that their favorite subject is English? So given that their favorite subject is English, I'm only looking at this column. So I got 85 to choose from. That they're in 7th grade, 38. Probability of 7th, given that they chose other. So we're going to the other column. We're looking only in this column. That's the given. We're out of 32. How many of them were 7th graders? 14. Find the probability of history given they're an 8th grader. So the bottom number is going to be 8th grader. So 182. probability given they're an 8th grader that they liked history, that number right there, 45. It's more just understanding how to read this table, but hopefully that makes some sense to you. A math teacher gives 2 tests. 25% of the class passes both tests, and 42% of the class passed the first test. What percent of the second test? What percent passed the second test, given that they passed the first test? So let's look at this. They gave 2 tests. Boom, boom. We are multiplying them together. This is test A. This is test B. They gave a test, and 25% of the class passed both tests. Notice that I put a multiplication sign, because what's the probability you passed A? What's the probability you passed B? If you multiply those two together, that will tell you the probability of A and B, 25%. 42% passed the first test. What percent passed the second test, given that they passed the first test? So this number right here, we're trying to decide that they passed both tests. All we're trying to do is solve this thing. 25% passed all, 42% passed here. How do I find B? Well, I'm going to take 25. This is some mystery number. I want to get the mystery number by itself. 0.25 divided by 0.42, because this is a multiplication problem. To solve for the missing number, I'm going to divide. So I'm taking 0.25 divided by 0.42. 59%, what we'll call it 60%, passed this test, which should make sense. If 42% passed the first, 60% passed the second, that gives us 25% of both. At a middle school, 32% of students play football. 18% students play football and basketball. So 32% here. 18% play both. What is the probability that a student plays basketball given that they play football? So we're trying to figure out that cross section of this. So 32% times some amount plays basketball. We're trying to figure out what percent plays football and basketball. To do that, again, it's a math problem. We are taking 0.18. We are going to solve for the missing number. So I'm going to divide by 0.32. So 0.18 divided by 0.32. What percent play basketball? 56.25%. That was my missing number. That is how many people played basketball, given 32% play football and 18% play both. Hope that makes sense. If not, ask me questions.